So we have already discussed about the k-folds cross-validation. Now we can actually utilize that k-folds cross-validation to do hyperparameter tuning. Before I explain hyperparameter tuning, let me explain hyperparameter first. So a hyperparameter is a configuration setting used in machine learning models that is setting before the training process starts. So you are setting it before the whole training process. And actually, those hyperparameters cannot be learned from the data. So it cannot be learned via the training itself. And those hyperparameters are essentially actually like controlling how the model learns. So for hyperparameter tuning, we are trying to find the hyperparameters that is able to yield the most optimal performance. So here, let's do the hyperparameter tuning using our KNN algorithm. So we are instantiating the KNN model for different values of the number of neighbors. We are running the tenfold cross-validation for each of the KNN model. And then we are sort of saving the average accuracy for each of the number of the neighbors. And then after that, we are going to select the most optimal number of neighbors. Now, let's get to the codes. So first, we create an empty list to store the results. So we let optimal being equal to an empty list. Then we start the loop. So for k in range from 1 to 26, so basically we are trying looping over the number of neighbors from 1 to 25. So now inside each loop, we are instantiating the classifier. So let KNN being equal to k neighbors classifier with n numbers equal to k. So for example, if we are at the first loop, k would be equal to 1. So we are just setting the number of neighbors to be equal to 1. Then for each of the loop, for each value of the k, we are running the tenfold cross-validation. So we are again using cross VAL score. And for the 4 inputs, we are inputting the KNN model, so KNN, and then X. So X is just our features, and Y is just our outcome variables or our labels. And here we set CV being equal to 10. So the CV equal to 10 here means that we are dividing the data into 10 folds. Let's just look at this figure here. So here we have 5 folds. So CV equal to 10, dividing our data into 10 folds. Then what we are doing in the next line of code is that we are appending accuracy score results to the optimal object, which is a list. So we use optimal.append. So for example, if we're still at the first loop, our k value is going to be equal to 1. So we are appending that 1. And also we are appending the average value of our k scores. So remember that the k scores is going to be like an array here containing 10 values. And the whole idea of the k-folds cross-validation is that we're going to take the average of those 10 values. So here, k-scores domain is that average performance we are looking for. Basically here, I'm trying to say that for each of the loop, we're appending 2 values to the list. One value being the current number of neighbors, the other value being the corresponding average performance based on the tenfold cross-validation. Optimal is still a list. So here, this line of code is trying to transforming that list into a data frame. We are setting the column names to be the number of neighbors, and then we are setting the other column name to be accuracy. So basically the k-scores domain, that's going to be the accuracy. And then we are also setting the index as this first column here. we are setting the index as the number of neighbors as our k. Then after transforming it into a data frame, we are plotting the accuracy for each k. So remember, we have k from 1 to 25. I'm just expanding the figure here because we are just plotting out that data frame. So on the x-axis, we are having the number of neighbors, or k, and on the y-axis, we are having the average performance of each k from the tenfold cross-validation. And to find the optimal hyperparameter, we have to basically looking for the highest values. Basically, the highest accuracy might be happening either here, here, or here. Let's try to look for the maximum value as well. So here, this is just a graphical illustration. Let's also try to numerically look for the maximum value. So let's print optimal. The maximum value is pretty much 0.98. Actually, we do have 3 optimal values here. So we can either use the number of neighbors being 13, or like the number of neighbors being 18, or the number of neighbors being 20 actually. So that's hyperparameter tuning. So you're just looking for the hyperparameter in our KNN example here, number of neighbors. So you're just trying to find the number of neighbors that's going to give you the highest out of sample accuracy.